Hello everyone, welcome back to another physics session. In this we'll discuss worksheet questions based on electromagnetic induction, EMI, not AMI, EMI. A metal disc of radius 30 centimeter, rotates with constant angular velocity omega equal to 100 radians per second. This is called data interpretation. You need to convert the data into symbols, then you can find out a good formula suitable to it. Find the magnitude of potential difference between the rim and the disk of external uniform magnetic field of induction. Magnetic field induction B is equal to 4 millitesla. Noticed. So answer will be in millivolt perpendicular to the disk. EMF produced equal to half Br square omega. So half B millitesla, so millivolt. R square 30 by 100 whole square omega 100 radians per second is a proper unit actually. 0 will go. So denominator 100, numerator 100 will go. This 2 will go. So 2 9s are 18 millivolt. So this is the answer. Yes. Next, a wire loop of area A is equal to 0.2 meter square has a resistance R is equal to 20 ohm. Magnetic field pointing normal to the loop has a magnitude of B is equal to 0.25 Tesla. Reduced to 0, B2 equal to 0 in a uniform rate 10 to the power of minus 4 seconds. The time taken is 10 to the power of minus 4 seconds. EMF induced is actually in this type of situations average EMF will come. Average EMF is equal to N A B2 minus B1 by time with a negative sign. Okay, here magnitude is only considered, so no issue. N number of turns is only one, a wire loop. Okay, number of turn is 1 into area is 0.2 and change in field is 0.25 to 0, that is 0.25 by time is 10 to the power of minus 4. This will be 0.5, 0.2, 25 are 0.05, 05 into 10 to the power of plus 4, that is nothing but 500 volts. What did he ask again? EMF and the resulting current. I is equal to E by R. E value 500 by R value 20 ohm. So it is 25 amps. So option B. A long solenoid, if you are strong at concepts and formulae, then you can do the sums easily. A long solenoid has 20 turns per centimeter. Long solenoid, N is equal to 20 turns per centimeter. Noticed. A small loop of area A is equal to 4 by pi centimeter square. Area is 4 by pi centimeter square. Okay, this is also in centimeters. Okay. If the current carried by the solenoid changes by, that means I can call it as di. Di equal to I2 minus I1. 3 minus 1, that is equal to 2 amperes in a time of dt is equal to 0.2 seconds. Okay, what is the magnitude of induced EMF in the loop while current change? Minus L di by dt. Where is inductance of the solenoid? We don't have. Long solenoid of number of turns is given. A small loop of area is given. Okay, and normal to the axis. The current carried by the solenoid changes steadily is given. Okay, so L is not given. L di by dt is the formula. Okay, loop while changing. Okay, minus L di by dt. L value can we find in any other way? L value can we find in any other way? Yes, L can be obtained in a different way. What is that? L is equal to, come on, L is equal to mu naught Na. So it is going to become E is equal to mu naught Na di by dt. So mu naught 4 pi into 10 to the power of minus 7 n 20 per centimeter 10 power minus 2 area 4 by pi into 10 to the power of minus 4 into di 2 by dt 0.2. So 5 pi gets cancelled, okay, blah blah blah, and I'm going to have the option is 3.2 microvolt. You can. Next, a circular coil of area A equal to 100 centimeter square and number of turns n is equal to 20. This is capital N I can use because number of turns only, not per number of turns per unit length. Magnetic flux density phi is equal to 2 Weber per meter square. Flux density means B, that is nothing but Tesla. Weber per meter square is a Tesla unit. It rotated from a position where the plane makes an angle theta 1 equal to 30 degrees to the field to a position perpendicular to the field. That means theta 2 is equal to 90 degrees in a time t equal to 0.2. The magnitude of induced EMF E is equal to how much? So induced EMF E is equal to NBA cos theta 2 minus cos theta 1 by time t. Number of turns 20, B value 2, A is area 100 into 10 power minus 4 into cos theta 2, cos 90 value 0 minus cos theta 1. Cos theta 1 will be cos 30 root 3 by 2, cos 30 root 3 by 2 by time 0.2. So that is equal to, it rotates 20 turns and it rotates from a position where the plane makes an angle 30 degrees with the field. Plane makes an angle 30 degrees with the field, not the normal. So this angle is with the normal. So that's why I checked here. Okay. Plane makes an angle, then obviously have to take cos 90 minus cos 30. What actually plane makes an angle, he said. So what you need to treat is, instead of cos, you have to take this one as sine, because plane angle he has given, plane. So this will become 1 minus 1 by 2. Then 1 by 2 will come. 1 minus 1 by 2 is 1 by 2. If you are taking angle with the plane, then sine you take. If you are taking angle with the normal, then cos you take. He didn't give with the cos, that's why. And this is 1 by 2, 2 will go. So 20 by 0.2 is 100, 100 into 10 to the power of minus 4. That's 1 only, 1 volt. Yes. So be careful in this aspect. A coil having number of turns n is equal to 100. It wound tightly in the form of a spiral with inner and outer radii. R1 is equal to 1 centimeter, R2 is equal to 2 centimeter respectively. When a current I is equal to 1 ampere passes through the coil, the magnetic field at the center of the coil is equal to B is equal to how much? Tightly in the form of a spiral with inner and outer radius. So radius R is equal to 1.5 centimeter average. Okay, B is equal to mu naught Ni. So mu naught Ni, and that is equal to mu naught n average radius, mu naught Ni. What did he ask? The magnetic field at the center of the coil is. Okay, so magnetic field B is equal to mu naught Ni is for only solenoid, but this is not like that. So this is mu naught Ni by 2R is the formula. Mu naught is 4 pi into 10 to the power of, even this one also won't come correct because it's a spiral one, right? We need to go for integration, no doubt. We have no other option. Actually, spiral means it is like this. It's like this. And he gave inner radius and he gave outer radius. Then intermediate one loop I have to take. That's magnetic field is dB. dB is equal to mu naught 1 turn, mu naught I by 2 R, that is x actually, that's radius is suppose say x, that's radius is x. Okay, x and into what I have to take, x radius, and it is having thickness of suppose a dx. In the dx thickness, that means in the dx thickness, how many loops will be there? How many loops will be there? That is R2 minus R1 by n number of loops. This will give you loop density. That is equal to dx by n number of loops. So this n is equal to dx into n by R2 minus R1. So these many loops will be there. And after integration, we'll get b is equal to mu naught in by 2 into R2 minus R1 into log of dx by x integration is log only, no, log x. And x is running from R1 to R2. So if I write R1 is inner one, R2 is outer one. That's my sense. So R1 is inner, R2 is outer. So R2 log R2 minus log R1, log R2 by R1. So mu naught in by 2 into R2 minus R1 into log of R2 by R1. Yeah, in this you need to substitute the things. Okay, I'll show you the substitution also later, you can continue. Yeah, b is equal to mu naught 4 pi into 10 to the power of minus 7, current I 1 ampere into number of turns 100 by R2 into R2 minus R1. R2 minus R1 is 1 centimeter into 10 to the power of minus 2 into log with base E only. R2 by R1, 2 by 1. Okay, units will cancel. So log 2 it is with base E. So other things can be simplified. 2 pi into 10 to the power of this will come 4 and 10 power minus 3 will be into ln of 2. Okay, any other things? 2 pi I got. 2 pi. Where is 2 pi? 2 pi, pi by 2 is there. Anything I missed? Oh, here one more 2 is there. Okay, that is correct only. I took. Let me check the simplification. Yeah, it's correct only. Actually, whatever the answer you got is correct. That is not 27, just 2 pi only. Here pi is missing. 7 is extra, unnecessary number. Option A is correct. Yeah, it's not 7, just 2 pi. 2 pi. I will change it in a minute. On the paper also I did it and it is correct only. I'll change in this. Wait. 2 pi, not 27. Once or twice we need to verify with the things, then only you can. Otherwise, you shouldn't fix the solutions. Okay. And Tesla. 10 to the power minus 3 will give you minus milli Tesla, not a big task. Next. So 10 power minus 3 is there, no sir. 10 power minus 3 is milli Tesla. Length of the solenoid L is equal to 50 centimeter and windings are 400. Capital N is equal to 400. What current must pass through it to produce a magnetic field B? 4 pi into 10 to the power of minus 3 at the center. B is equal to mu naught Ni. B is equal to mu naught N by L into I. And he is asking current, right? What's the current? Current I is equal to B L by mu naught N, right? So that is equal to I is equal to B 4 pi into 10 to the power of minus 3. L is 50 into 10 power minus 2 by mu naught 4 pi into 10 to the power of minus 7 into number of turns 400. 50 ones 50 100 2 4s are 8. Okay, 4 pi cancel. Okay, 10 to the power of minus 5, 10 to the power of, so 100 by 8 it will be. 100 by 8 means 12.5. Next, two straight conducting rails from right angle form right angle as shown in the figure. Fine. The conducting bar is in contact with the rails, starts at the vertex t equal to 0, moves with constant velocity 5 meters per second. constant velocity 5 meters per second. Then magnetic field B is 0.1 Tesla at that region, directed out of the edge. Fine. The absolute value of the EMF around the triangle at the time t equal to 4 seconds will be EMF is equal to how much? So EMF is equal to how much if it starts from t equal to 0 onwards, right? Yes. The picture is given like this. Let me draw a somewhat bigger one. Suppose this is at a height y. This is at a height y. It's a straight line, okay, y. Now, what is the area of this so-called triangle? Because flux is passing through it. Flux is passing through the area. So, the rod is falling. Obviously, flux change in the area wise. You need to think in such a way. So, formula for EMF is EMF from Lenz's law, right? NBA B A dA by dt. So, this will become the basic formula. So, what is the area of that? Area A is equal to half into, this is 90 degrees he said. It will be 45 degrees. It will be 45 degrees. If it is 45 degrees, then this is all, this side and this side will be equal. This one and this one will be equal. This one will be equal. That means if it is y, this will be 2y at an instant of time. If it is y, this will be 2y. So half into base into height. Half into base into height. Y gets, 2 gets cancelled. It will be y square. So what will be dA by dt? dA by dt is d by dt into y square. That is 2y dy by dt. dy by dt is at what rate that y value is changing? The rod is falling with velocity v, right? That only. So dA by dt is equal to 2y into velocity. So dA by dt came. But what about y value? Y value he gave after some seconds. 4 seconds after, right? The absolute value of EMF induced in a triangle after a time t equal to 4 seconds. How much distance it can cover in 4 seconds? Distance covered y is equal to Vt. Y equal to Vt. V value 20, V value 5. 5 into t value 4 seconds. So total 20 will come. So this 20 you can use. Now EMF is equal to B into dA by dt is equal to B into 2y V, right? Because dA by dt is 2ay. So EMF is equal to B value, B 0.1 into 2 into 20 into velocity 5. So 25s are 100. So 10 twos are 20. So 20 volts will be calculation. Yes. Next, consider a current in a circuit falls from I1 is equal to 6 and I2 is equal to 1 in time t equal to 0.2. The average EMF E is equal to 150. Average EMF is equal to 150 induced in the circuit. Then self-inductance L equal to how much? E is equal to L di by dt. That is equal to, we want L. L is equal to E by di by dt we need to do. So E value 150 by di by dt is change in current is 5. By change in time is equal to 0.2. Its simplification gives rise to 6 Henry. Right? Let's go to the next problem. R is equal to 10 ohm. Number of turns is equal to 180. Diameter 4 centimeter. Noticed. Is placed in a uniform magnetic field that produces magnetic flux is maximum through the coil. That means correct position BA. Cross sectional area so as to flux maximum flux. The field is suddenly removed. A charge of Q is equal to 360 microcoulomb flows through a resistance R is equal to 618 ohms galvanometer connected to the coil. Find the magnetic field. This is galvanometer resistance. Find the magnetic field B value. EMF is equal to EMF is equal to N A dB by dt. Here B only became 0 or it is removed. That means flux can be 0. Why should I write all this? Flux 0, flux maxima he said, right? So I can go like that only. So simply speaking, d phi by dt, just magnitudes. And current I is equal to EMF by resistance, which is equal to d phi by dt, d phi by r dt. And the charge q is equal to I dt, that is equal to d phi by r. So flux change, okay, this is NBA by r is equal to q. So B is equal to QR by NA. All the things are known. B is equal to Q value Q 360 micro Tesla, micro coulomb 10 power minus 6 into resistance 618 and 10. Total you have to take 628 by N value, number of turns 180, and area pi r square. From this I can go for pi r square. Pi r square, that is pi only, and r square, r 2 centimeter, 2 into 10 power minus 2 whole square. So this one is area is equal to 3.14 into 2 into 10 to the power of minus 2 whole square. So B is equal to 180 will go 2 times, 3.14 will go 2 times, here 200 times then. So 400 and into 10 power minus 6 by denominator 4 into 10 to the power of minus 4. This totally it's coming 1 Tesla. So simplification you can do, I no need to do. A coil has inductance of L is equal to 0.4 Henry and resistance R is equal to 8 ohm. It is connected to an AC source with the peak EMF 4 volts. Peak EMF 4 volts and frequency FRN is equal to 30 by pi. The average power dissipated in the circuit P equal to how much? L is given, R is given, EMF is given, frequency is given, power dissipated he is asking. EMF is equal to NBA omega sin omega t. Power is equal to V into I. NBA omega sin, that is NBA omega cos omega t. Any other short way for this? This can be done in this way. This is inductor, this is a resistor connected to an AC source. This is LR. So Z is equal to square root of XL square plus R square, right? Then only current will come, otherwise how can I get current? So square root of XL omega L square plus R square. Z is equal to square root of 2 pi FL square plus R square, that is equal to square root of 4 pi square F square, frequency 30 by pi, 30 by pi square plus R square. R square is 8 square. Pi square will go 900, 904s are 3664. Any CGS units? No. Yeah, 3600, 904s are 3600 plus 64. So it is 3664. Will it exist a root? 62 or 62 62s are 2 2s are 4, 2 6s are 3 7 are. It is 3 6 only there. Rough value I will take 62. I will take 62 ohms. Next, cos phi is equal to R by Z. R value 8, Z value 62. This is also 1 by 8 roughly. Rough values only I am taking. Now current I is equal to V by R. V is 4 by R value. Is it peak voltage? Okay, peak voltage by R value. V by Z. 4 by 62. 4 by 62 is 64 if I can feel. Then 64 is 1 by 16. Okay, fine. Now power dissipated is equal to half V naught I naught cos phi. Half into V naught value 4, I naught value 1 by 16, cos phi value 1 by 8. So 2 times will go, 8 times will go, 1 by 8 8s are 64. 1 by 64 watt. 1 by 64. Very less value will come. It will be 0.01, 0.1. But I got 0.01, very less value. I'll check the calculation. Calculation in another way can be power consumed is equal to V square by Z into cos phi also one can do with half. Then V square means 1 by 64 into Z value we got 62. Of course we can take it as 62. Okay. V square. So into 1 by 64. Okay, 64 I did already. Then into cos phi value 1 by automatically it is also 1 by 16 will come. Oh, V value substitution wrong. 1 minute. V value 4, right? 4 4s are V square. V square means 4 4s are 16. By Z value 4 4s are 16 and Z value 62. Okay. And cos phi value, what we got? Cos phi 1 by 8. 1 by 8 into 1 by 2. So 16 will go 1 by 64. Same answer is coming. So maybe correction in the option. 1 by 64 roughly comes as, yeah, it should be 0.015. I'll correct it later. It should be 0.015. What is this? What did we find? Power. So what? Next. You to check the calculation, but procedure is this one only. Next. A generator with a circular coil of 100 turns. N is equal to 100 turns. A generator with a circular coil of 100 turns. Of area A is equal to 2 into 10 to the power of minus 2. 2 into 10 to the power of minus 2 meter square only, and immersed in B is equal to 0.01 Tesla. Magnetic field and rotated at a frequency F is equal to 50 Hertz. And the maximum EMF which is produced during the cycle is equal to maximum EMF, Emax is equal to NBA omega. N value 2 into 10 to the power of minus 2. B is 0.01 10 power minus 2. A is area. Hey, N is 100. Okay. N 100. Okay, I wrote this area here and N there. Okay, no problem. And omega is 2 pi F. 2 pi F is 50. So that is equal to 2, 50. 52s are 100, 102s are 200. 200 into 10 to the power of minus 2 pi. So it is just 2 pi I got. 2 pi means 3.14 into 2, 6.28. Suppose the electric flux inside a parallel plate capacitor changes at a rate of d phi by dt is changing at a rate of 7 into 10 to the power of 14 unit per seconds. Okay. Then the magnetic induction field density at any point inside the capacitor is, okay, and the plate area A is equal to 1 meter square, and permittivity of free space epsilon naught value is given 8.8 into 10 to the power of minus 12 units, and the mu naught value anyway we know. He is asking which one. Then the magnetic field induction B value he is asking. Okay. Integral B dot dl is equal to actually I can say that flux phi is equal to 1 by epsilon naught times of charge enclosed in it, right? So d phi by dt is equal to 1 by epsilon naught times of dq by dt. dq by dt is nothing but I. So I by epsilon naught. Next, anything he has magnetic field induction at any point inside, and electric flux change. So this is electric flux change. So now I can write I is equal to epsilon naught times of d phi by dt is what you call current, id, displacement current. Now integral b dot dl is equal to mu naught times of displacement current, epsilon naught d phi by dt. So he is asking electric field density at any point inside the capacitor. So you can take up the plate of area of the plate 1 meter square. So from that b into dl, b into 2 pi r you can take. B into 2 pi r is equal to mu naught epsilon naught d phi by dt. So he is asking b value. B is equal to mu naught epsilon naught d phi by dt into 2 pi r. After substitution, we can have the answer. Yes, that is area by L. M is proportional to area by L. Area by L means M is proportional to L square by L. So L square by L is, which option? B. A circular coil of area A is equal to 0.01 meter square and number of turns is equal to 40, rotated about a vertical diameter with an angular speed omega is equal to 50 radians per second, and a uniform horizontal magnetic field B is equal to 5 into 10 power minus 2. The average power loss due to joule heating is equal to 25 milliwatt, and then closed loop resistance of the coil R is equal to how much? I think in the conversion, in the conversion area 10 power minus 4, right? Yes, that mistake I did. 10 power minus 4. So it is going to become 10 power minus 4. Then 10 power minus 1 into 10 power minus 3. That means 0.1 millivolt. Yes, 10 power minus 4 it is. A metal loop of area A equal to 10 into 10 to the power of minus 4 meter square is placed in a region which is k cap, and magnetic field induction B equal to 1.73 in a position I plus j plus k. It's a position, it's not a position vector. If you divide with root 3 its magnitude, then only position vector will come. If it is switched off, field decreases from 0 to that extent is 10 seconds. Then what is the magnitude of induced EMF? Induced EMF is flux change by time. Flux is equal to B bar dot A bar by T, and B bar dot A bar is dot product of this. Here it is K, and K only will come. So 10 into 10 to the power of minus 4 into 1.73 by root 3 by T is equal to 10. 10 will go, and root 3 will go. So 10 power minus 4, which is nothing but 0.1 millivolt. So option A, yes. A plane electromagnetic wave travels in free space along z-axis. At a particular point in space, the electric field along x-axis is 8.7 volt per meter. The magnetic field along y-axis is equal to how much? E by B is equal to C. So B is equal to E by C. E value 8.7 by C value 3 into 10 power 8. So this will go 3 2s are 6, 27, 9. So 2.9 into 10 to the power of minus 8 Tesla. Next, reactance of an inductor at 50 Hz. N equal to 50 Hz is 10 ohm. Reactance of an inductor XL is equal to 10 ohm. Reactance of it at 200 Hz is equal to, at 200 Hz. If N equal to 200, then XL is equal to how much? XL is equal to omega L 2 pi FL So this is directly proportional. How many times n became? N became 4 times. Then it will become 4 times. So 40 ohm it will come. So B option. When a plane of a coil is perpendicular to the magnetic field, magnetic flux linked with the coil is minimum. Plane is perpendicular, but induced EMF is 0. Phi is equal to NBA cos theta. Theta is with the normal, not with the plane, right? If it is perpendicular means cos 0, that is maximum only, yes. E equal to d phi by dt. If you consider sign, if negative sign is missing, otherwise even both are false. So A is false, R is true. D is preferable answer if you ignore even minus sign. D, yeah, here even minus sign is there, that is also ignored, otherwise even this also can't be taken. Okay, next. The unit of magnetic induction. Magnetic induction is B. B is Weber per meter square. Next, the energy stored in 50 millihenry. Energy carrying current 4 amperes. Energy stored, U is equal to magnetic field energy is equal to half Li square, right? Half Li square, half L value 50 into 10 power minus 3 into I square is 4 4s are 16. 2 will go 8 times. 8 50s are 400. 400 into 10 to the power of minus 3 Joule. So 0.4. Energy stored in a coil of inductance L carrying steady current I is in the form of inductor always carries magnetic field current, magnetic field energy. So magnetic. Concentric coplanar circular conducting loops are R and R. The mutual inductance is proportional to R square by R. So option is C. Just in the previous question we got L square by L. This is also like that one. And two coils have mutual inductances. M is equal to 5 into 10 power minus 3 Henry. And the current changes from the first coil according to the equation I is equal to Im sin omega t. And Im is equal to 10 amperes. Okay, this is 10 amperes. And omega equal to 100 pi radians per seconds. Maximum value of EMF induced in the second coil is maximum EMF. That is equal to what we got, M di by dt, M di by dt. Yeah. I is given, why don't you go for di by dt? Di by dt is equal to I omega cos omega t. I omega cos omega t we can take maximum, then its maximum value you take, so I omega only. That means M I omega. M value 5 into 10 power minus 3, I value 10 amperes, and omega value 100 pi. 100 pi. So 10 power minus 3 will go, it will be 5 pi then. Use some mathematical techniques, dear. Next, conducting, any picture? Yeah. Length 1 meter, speed 2, and magnetic field is 4 Tesla on the paper. Capacitor of capacity 5 microfarad connected to it. The charge on the capacitor plate is EMF is equal to BLV, and charge Q is equal to CV. CV, that is C into BLV. C value 10 microfarad. Microfarad will give you microcoulomb of charge. So nothing else. So I will put 10 only. 10. B value B 4 Tesla, L 1 meter, and velocity 2 meters per second. Okay. So it will be 4 2s are 8 and 80. 80 microcoulomb. 80 microcoulomb is the charge. What is next to B? The charge on the plates of the capacitor are, okay, which one positive, which one negative? Fine. Use right hand thumb rule. Okay, Fleming's. That is field and motion. So current upwards. Current is going like that. That means it's a cell. You can see current is going like this in a cell. In the cell, current goes from negative terminal to positive terminal. So upper plate will have positive, lower plate will have negative. Upper plate QA QB. As per that, you can take option A, I think so. Yeah. Two concentric coils of 20 turns. Two concentric coils of 20 turns. N1 is equal to 20 turns each. That is equal to N2. Their radii are R1 is equal to 30 and R2 is equal to 60. Carries a current I1 is equal to 0.4 and I2 is equal to 0.6 amperes respectively in opposite directions. The magnetic induction at the center in Tesla, maybe they are concentric, yeah. So B1 minus B2 will go. Why? Because they are opposite. So B1 is equal to mu naught Ni by 2R minus mu naught Ni by 2R of the first one and of the second one. So mu naught by 2 is only common. N1 R1 N1 I1 by R1 minus N2 I2 by R2. You substitute and simplify, not a big task. Next, a metallic rod of length L equal to 1 meter held along east-west direction. A metallic rod of length 1 meter held at east-west direction. Metallic rod of length 1 meter held at east-west direction. Come on. Okay, east-west direction. Like this. East, Bay of Bengal. West, Goa. Not Arabian Sea. I'm a bad boy. And north, south, east, west. Okay, magnetic field will be like this. BH. So it is cutting BH. It's cutting BH freely. Given horizontal component of Earth is this one. The induced EMF at an instant t equal to 2 seconds after its release. BLV formula. B value BH 3 into 10 to the power of minus 5. L equal to 1 meter. Velocity after 2 seconds is V equal to GT. 10 into 2 seconds 2. So this is 6T. So 0 will go into 10 to the power of minus 4. Option volts. Side 2 centimeters. Magnetic field at constant speed of 2 centimeters per second is shown in front of the edge enters, front edge enters, and which of the following graph will correctly represent the induced EMF in the loop? Take clockwise direction as positive. When enters, first rod enters, then EMF will be generated, and it is moving with constant velocity, then BLV will come, and until the second rod also enters, BLV will be continued. Once the second rod also enters, then it will become 0, and the first rod leaves, then automatically negative will come. Yes, until the last one comes out. So option will be clockwise direction, anti-clockwise direction. So that is field moving like this, upward current. Upward current means anti-clockwise. What he said, take clockwise direction positive. So first negative and then positive. So fourth option will come then. Long solenoid of number of turns n is equal to 500 turns. When a current of I is equal to 2 ampere is passed through it, the resulting magnetic flux linked with each turn in the solenoid is flux with each turn is equal to 4 into 10 to the power of minus 3. The self-induction L is equal to 5 by I. 5 is equal to 4 into 10 to the power of minus 3 by current is equal to 2. If you calculate for 1 or whole, that will be same only. That is 2 times of 10 power minus 3. 4 by 2 amperes. Yeah. So this is 2 into 10 to the power of minus 3 into 500 will give you N5 is the total flux, right? So that's why 2 5s are 10, 1000. So 1 Henry will come. 1 Henry means option C. Yeah. Current in the coil of inductance L equal to 0.2 H changes from delta I is equal to 5 to 3 amperes in 5 seconds. T is equal to 0.5 seconds. The magnitude of average EMF induced V is equal to L di by dt. L is 0.2, di is 3, dt is 0.5. That is equal to 2 3 by 5. 2 3s are 6 by 5. That is 1.2. Done. Yes. Next, consider situation. Okay, rod AB fixed rails constant velocity. If the wire AB is replaced with a semicircular wire, the magnitude of the induced current. Magnitude of induced current, even though it's a semicircular wire, effective length only we have to consider, right? So increase or decrease depends upon the semicircular bulges towards. No, it's remains same in my point of view. Yes. Now questions from alternating currents. Are you ready to enjoy? Yeah. Let me change another color. A capacitor of capacitance 100 microfarad, mu is equal to capacitor of capacitance C is equal to 100 microfarad. Coil of resistance R is equal to 20 ohm. Inductance L equal to 12.5 millihenry. First need to identify the units. Are connected in series with V equal to 220 volts and 200 by pi hertz, frequency 200 by pi hertz, AC source. Okay. The maximum value of instantaneous current, I instantaneous we got V by R. So E by R is general formula, but here capacitance is there, inductance is there, so obviously it will have Z, E by Z. What is Z? Z is equal to square root of XC square plus R square. Inductor is also there, right? Yeah, so 3 are there. It's an LCR series circuit. So it is an LCR circuit. So too, here C is there, R is there, L is there. So XL minus XC whole square plus R square. That much we need to do. XL is equal to omega L, that is equal to 2 pi FL. XC is equal to 1 by omega C, that is equal to 1 by 2 pi FC. And R value is given. So you need to substitute in it. Z value should be obtained. After obtaining Z value, you need to go for E by Z. Here E value, whatever given is RMS value. I think he is asking maximum value. So RMS value into root 2 you have to take. 220 into root 2 you need to do by Z value whatever obtained. I obtained Z value is almost all 25 ohms, I think so. 20 root 2. So that 20 root 2 we are going to apply here. So it will become root 2 will go, 0 will go. So 11 amps will come. And for your kind information, let me do some more steps for you. 2 pi frequency 200 by pi into L 12.5 millihenry 10 power minus 3. So this is going to become XL value 5 ohms, and this is going to become 25 ohms. So it's substitution 20 square plus R square 20 square. So 20 root 2, yes. Then substitution, right? Hope you can enjoy it. Resistor of resistance R is equal to 100 ohm. Connected to an AC source of EMF is equal to 10. Okay, why should I? Sin 250 pi t. The energy dissipated as heat during G equal to 0 to 1 second. Energy dissipated during heat from T equal to 0 to 1 second. We have power is equal to V square by R. Power is nothing but rate of doing work, that is nothing but heat by time. So heat is equal to V square by R into T, but here it's a variable EMF. How can you take V value? For that what you need to do is heat produced is equal to 1 by R integral E square into dt, instantaneous value into time t. So if for at every instant how much heat is produced, it is nothing but V square by R into T only. So let me give some more simplification. E square, that is 10 square sin square 250 pi t into dt, and time is 0 to 1 second. I think he is asking 0 to 1 second. It simplifies to 0.57 by pi, nothing but millijoule, nothing but first option. And AC current is in the expression I equal to blah blah blah, the frequency of RMS value, the frequency and RMS value of current respectively. Frequency comes with time quotient, right? Time quotient is equal to 200 pi, which is omega, which is 2 pi f. So f is equal to 100 hertz, and I naught is equal to 50, and IRMS value is I naught by root 2, that is 50 by root 2. 50 by root 2 means 25 root 2. Yo. V is given. Amplitude of output voltage V0 at right end across the capacitor will be amplitude of output voltage V0 at the right end amplitude of V0. Okay, output he is asking. Okay, capacitor will read always maximum EMF, right? Capacitor will give you maximum EMF. AC is given 100 ohms. Okay, current is not given. Okay, 20 millivolt. 20 millivolt is peak value, V0 value. Vrms is equal 20 by root 2. No, peak value only will be given by it actually, right? So 20 millivolt. So, what happened? Yeah, it is not an DC circuit, AC circuit. So, we need to go for lengthy procedure. That means voltage applied will be shared among the resistance and the capacitance. So voltage applied shared among these two. So obviously we need to go for the total reactance. So total reactance G equal to square root of XC square plus R square. So that square root of 1 by 2 pi FC whole square plus R square. It's almost all after substitution you are going to get 1000 ohms. This is Z value. Z value, if it is 1000 ohms, why should I waste time? XC only 1000, not the total value. Total value 1000 root 2, sorry. 1000 root 2. XC only 1000. This is 1000 root 2. Now, current I is equal to V0 by, if it is I0, V0 by Z. That is 20 millivolt by 1000 root 2. So, already this is also milliamps. After this, what you can get is, so this is 2 root 2, only root 2, root 2 into 10 to the power of minus 5 amperes, which is I0 value. Now voltage across capacitor is equal to I0 into XC. Voltage across I0 is root 2 into 10 to the power of minus 5 into 1000, it is 1000 ohms, we will get XC value. X equal to 1 by 2 pi FC, that is equal to 1000 ohms will come. Just substitute. So frequency is given from that, and you will get. So what is this? What is this? This is root 2 into 10 to the power of minus 2. Root 2 into 10 power minus 2 amps, or I can multiply with 1000 also. So that 10 root 2 milliamps. 10 root 2 milliamps means 1.414, so 14.4. So option A. LCR unda, RLC, okay, shown below is given by an ideal AC source. The frequency F is equal to 1 by 2 pi root LC. Choose the correct statement. Frequency given is 1 by 2 pi root LC. Okay, the current through R is 0. The current through R is 0. But the current through R is infinite. The current through R depends on the value of L and C. The current through R depends only on R, L, not C, but not L and C. Actually here, the in between wire is connected or not, that I want to check. Let me check it. Actually in the figure, this line is not present. This is absent. So obviously in resonance condition, under resonance condition, current strictly depends upon R but not on the other things. So option is B. VR. The current through R is infinite. Option should be D. Option should be D. Let me change it. Why should I waste time? I'll write here only. Option should be D. The current of 6 amperes, I is equal to 6 amperes flowing through 220 volt primary coil of transformer. If the voltage produced in the secondary coil is primary, secondary coil is 1100 volts, and 40% power is lost, 40% waste. That means 60% effective. 60% effective. then the current in the secondary coil will be current in the secondary coil I secondary equal to 40% of input power, 60% of input power V into I is equal to output V into I. This is input in. This is out. 60 by 100 because 40% lost. Input means primary. Primary is called input, secondary means output. And this is input. So 220 into 6 is equal to V output 1100 and V out, I out. So simplification, 0 0 will go and 0 0 will go, and 6 into 22 by 10 into 11 is equal to I naught. 11 will go 2 times. 6 6 are 36, 2s are 72. 6 6 are 36, 36 2s are 72, 72 by 10. Is there anything missing? The current in the secondary coil will be, so I naught is equal to 0.72 amps. Actually it was printed 4.2, I changed it now, 7.2. An inductor coil is connected to a capacitor and an AC source of RMS voltage 8 volts. An inductor coil connected to a capacitor and an AC source. Inductor coil, capacitor and an AC source. Okay. 8 volts. Okay. The RMS current in the circuit is 16 amps. I is equal to 16 amps. In phase with EMF. If the inductor coil is connected with 6 volts DC, inductor is connected with 6 volts DC. This is 6 volts only. Okay, here, okay, let me finish. The magnitude of steady current equal to, here current equal to how much? Actually, whenever inductor and capacitor are only present, either inductor should lead or conductor should lead. That means either current should be leading ahead by pi by 2 phase or lagging by pi by 2 phase with voltage. It cannot be with in phase. If it is in phase means one thing you can expect, that is there is an additional resistance, inbuilt resistance in the inductor, so that XL is equal to XC such that the net reactance because of this 2 is 0 and Z is equal to only R. So V by Z is equal to I, that is equal to 16 amps is equal to 8 by R, implies R is equal to 8 by 16 which is equal to 1 by 2 ohms. Now that ohm is here also is applicable. R is equal to here 1 by 2 ohms. Then current I is equal to V by R, 6 by 1 by 2. That means it's going to give 12 amps. Yo. Consider the solenoid carrying current supplied by a DC source with constant EMF containing iron core inside. When the core is pulled out the solenoid, the change in the current is just actually, okay, this is actually decreases. Wait. What is telling? This is a solenoid, okay, having current, and now core is removed out. As it is removing out, you are decreasing the magnitude of the what you call magnetism. As you are decreasing, it should try to automatically increase should come. Yes, increase, because magnetic field decreases. It should oppose. So obviously increase should come. Okay. Next. Okay. Next one. Capacitive reactance of capacitor of AC circuit is 3 kilo ohm. Capacitive reactance is 3 kilo ohm. At this capacitor is connected to a new AC source of double frequency. If this capacitor is connected to a new AC source of double frequency, that means F dash became 2F. Okay, the capacitive reactance will become, capacitive reactance formula is XC is equal to 1 by 2 pi FC. So XC inversely proportional to F. If F is doubled, it will be halved. So directly one can tell X dash is equal to X dash is equal to capital X, we use it to write 1.5 kilo ohm then. So option is A. Next. Two inductor coils A and B are connected in parallel. Whenever inductors are connected in parallel, 1 by L equal to 1 by L1 plus 1 by L2 follows. Single inductor inductance L effective is equal to 1.5 Henry. When connected in series, the equivalent is, okay, this is parallel connection. And series connection 8H, L1 plus L2. Then find the difference in the inductances. So this is L1 L2 by L1 plus L2. This is L1 plus L2, L1 plus L2. So from the second one, the first one will become L1 L2 by 8. So on cross multiplication, you will get N1 L2 is equal to 8 15s, 8 into 1.5s. 90, yeah? 8 to 8 5s are 120, yeah? Correct, 120 after 0.2. So it is 12 Henry. Okay. So L1 L2 is 12. Now L1 minus L2 is equal to root over L. Some mass you need to know. Without doing knowing mass, you can't do anything in physics. So L1 plus L2 whole square minus 4L1 L2. So that is equal to square root of L1 plus 8 square minus 4 into 12. So 48. I know now why negative number came, shouldn't come, right? 8 to 8 5s are 12. 12s are 4 L1 L2. 8 8s are 64 minus 48. Yes. Under root. How much? 64 48, another 16 I think. 16 root will be 4. So 4 Henry. Keep on working. Some variety models of AC we have discussed. Continuously work until you reach the goal. Keep on working. Push yourself to your great future. Bye.